Today I will graph linear inequalities by reading slope, y-intercept, and inequality information.
Beautiful. So we've got a lot going on today. We're graphing linear inequalities, and we're going to be reading things like slope, things like y-intercept. Where does that sound familiar from?
What was that, miss?
We're going to be reading slope and y-intercept. Where is that familiar from? We did it yesterday, guys. That's how you graph lines, right? You put it in slope-intercept form, you read your slope, you read your intercept, you draw your line. What we're adding today is that inequality information, the idea of stuff being less than or stuff being greater than. All right, here's the difference. Linear equations, just the line, nothing else. Inequalities, we're going to color either above or below the line. And as an added bonus, lines now can be solid or dashed. Let's figure out which is which. If it's a solid line, our inequalities have the or equal to bar. It's like a little anime face going, but they're blushing, so they've got the little line under their eyes. The dashed line is just the inequality, less than or greater than, without the line underneath. That's it, that's the only difference. When we're shading above, we're going to be using greater than. Super important with these that the y is on the left side of this symbol. If greater than shades above, what do you think shades below? Yeah, less than. All right, we have all the information we need. Let's graph these inequalities. Let's start with this one here on the right. What do I do? Graph the line. Yeah, we're going to do the second one. Graph the line. What do we do?
3.
3. Okay, positive 3. Where do I put that?
Between 4 and 2.
Okay.
On the y-axis.
On the y-axis. Thank you for being so specific. I would have messed up and put it on the x-axis. This is the y-intercept, goes on the y-axis. Nicely done. Now what?
You could put a 1.
2 over 1.
Okay, I can put a 1 under the 2. Good.
And then you graph.
And then I graph. Okay, what do I do, though?
You go down the 2.
Right?
Down 2 to the right 1.
Down 2 to the right, and then up 2 to the left.
What do you say?
Beautiful, because this is a negative slope, so I can go down and to the right, or I can go up and to the left. Whichever one you like the best. And then you'll grab your handy-dandy protractor. Can I borrow yours? I totally didn't grab one. What was hilarious? Oh,
I tried to get
you tried to help me out and you missed. You are not Batman, dude.
Oh, it's offensive.
All right, but this is an inequality. So my line is either solid or dashed. How do I know which one it is?
The sign.
Okay, the sign,
It's greater than or equal
it's greater
to.
than or equal to, so you're saying it's
Solid.
it's solid. This right here is telling me that it's a solid line. So the way I drew is perfect. Now I need to shade it.
Oh, yeah.
Do I shade above or below?
Above.
How do you know?
Because
It's greater than.
Because it's greater than, and my little key up here said greater than, shade above. All right, this is everything above the line. And you just color it the best that you can. Ta-da!
So
You
how do you
can't
shade it below?
You shaded below?
No, but how do you shade it if it is below?
Oh, how do you shade it if it is below? We'll do the next example and you'll see that.
Where did I put up your phone?
There we go, that's a better shading.
Right, if you insert this in the calculator, it comes out shaded too.
Yeah, if you stick in the calculator, come out shaded too. I want you to recognize it by hand first, and then after you've gone, this is how I want to shade it, then go to the calculator, punch it in, and go, yes, I wanted to shade it in the right spot. But don't do it the other way around, because then the calculator's doing the thinking for you, and you're just being a little lump on a sofa, not doing anything. Okay? All right, let's graph this guy, because you wanted to see what it would look like shaded below. All right, what do I do? Negative 1? Right here?
No.
Oh, here. Oh. Now what?
You put X over, no.
You can do 1/1, right?
Yeah, I could do 1/1 on my slope because I don't have a coefficient. Coefficient is 1. I don't have a coefficient showing, I should say. All right, so then with my slope of 1, what do I do?
Go forward.
Down, I mean, up.
Down and to the left or up and to the right? Good.
Oh, yeah.
Yeah, beautiful. You guys are getting great at this. Makes me happy camper. Eh. Again, super important that you cover the entire grid paper we gave you. All right, look at the symbol. Solid or dashed? Dashed? Okay. So it's dashed. I drew it solid, so I need to put dashes. If you're writing with something that can erase, just erase bits and pieces of it so that it looks dashed. Okay? And everyone will be like, ooh, magic. If you're not drawing in something that can erase, you should probably change to something that can erase. You can use a marker or highlighter and color over it as a dashed line. Okay? All right, now we're going to color below, which is what was your question? Okay? Less than color below, that's down here.
Mm.
Notice how I'm not coloring on the other side of the line. This is very much a kindergarten color in the lines moment. I failed that very badly. Cool? Yep. All right. Let's check the back. We've got some more. I've got 3 more. Take a look. Tell me which one of these 3 you desperately need to see.
The first one.
No.
The first one, because it's got a fraction?
Yeah.
That fraction is just your slope, dude. Top number is vertical, bottom number is horizontal.
Oh,
Yeah.
then number 2, I guess.
Number
There's
2?
No y-intercept.
Okay, the number 2. Do you guys want to see number 3 also? While we're at it? All right. Hey, dude, put it away, man.
Some for everybody. It's a
No,
100.
no, put it
You know what they
away.
say, like,
No, put it away.
Bring some for everybody.
Which I appreciate. Put it away, man. Dude. Dude. All right. I need to graph y less than 2. I'm going to think about this as an equation first. I'm going to find 2 on the y-axis. And then I got to ask myself, the slope, positive, negative, 0, or undefined?
Undefined.
Undefined is a vertical line.
Oh, yeah, that's 0.
0. Because what this is saying is y is always going to be at this 2 line. So y is always 2, and if I mark all the points where y is always 2, I end up with that kind of line. So this is a horizontal line. So I want you in your brains, when you see y equals just a number by itself, or an inequality number by itself, it's a horizontal line. All right, taking my straight edge that I borrowed from my buddy over here. Solid or dashed? Solid, because it says or equal to. Now it wants me to shade less than. It's a below kind of thing. All right, so I'm going to shade this way. Cool. Slide it on over. Let's do this one. We've got an X with a number by itself. Where do I put this thing?
The negative 1.
Great. But on the x-axis or the y-axis?
On the x-axis.
On the x-axis, because we're talking about x things. If we're talking about y things, we put it on the y-axis. But now we're talking about x things, so I'm going to stick it on the x-axis. All right? These are vertical lines. So undefined slope. Thank you again for lending this to me. Solid or dashed? Dashed. Okay, so since I know right off the bat that it's going to be dashed, I'm going to go ahead and draw it as dashed so I don't have to go through and erase. La, la, la. Where do I shade?
Above.
Okay, according to our notes it says above. There's a problem though. This is a vertical line. There's no such thing as above. Like, that doesn't work.
Is it the right side?
Yeah, it's the right side. You're looking for numbers that are going to be bigger than -1. So as long as you pick numbers bigger than or -1 and you shade in that area, you're good. Lovely. Last things. How do we know if stuff is a solution? With the linear function, to know if it's a solution, it's got to be on the line. With an inequality, to know if it's a solution, it's got to be in the shaded part. The line counts as the shaded part if it's solid. If it's dashed, it don't count as the shaded part. With me so far? All right, let's graph this thing. -4, comma 5. I'm going to start at the origin. I'm going to go to -4, and then I'm going to go up to 5. Right here. That's a 6. That was a typo. Is that in the shaded part?
Yeah.
All right, this is part of the solution. Let's graph the next one. 0, -2. Part of the solution? 6, -8.
No.
Yes.
She said no. I was just copying out what she said.
No, yeah, it's no. No.
Oh, it is no?
Yeah, it's no.
Okay, why not?
No, that's because I thought it was a -6, that's why.
Gotcha. Because it's not in the shaded part. Good. All right, let's take a look at this one because it's slightly different. We have a dashed line. Remember what we said, dashed line, not part of the shaded, not part of the solution. All right, 3, 3. Yes. 1, 2.
Yes, yes.
Have that
Yeah.
argument. Some are saying yes, some are saying no.
I'm saying yes.
Yes,
Yes.
miss.
Argue. Why are you saying yes? Why are you saying no?
Why you saying no, huh?
Why do you say no?
Because it's inside the line.
It's outside the line.
It's right on the line.
It's on
Okay, it's on the line.
It's not inside.
The line is dashed. Dashed means part of the solution or shaded, not shaded.
It's not in the line, but it's not outside the line.
It's like on the dashed line.
But it's inside the
But
line.
that would be considered in it.
You're right, it's on the line. The question is the line considered part of the solution?
Yes.
No. What we had said when we came to this part is if the line is solid, it's considered shaded in. If it's dashed, it's not shaded in.
Am I correct?
You are correct, it's not part of the solution because the line is not shaded. So I want you to take like 30 seconds and I want you to write something to yourself that tells you that. Line is dashed line, not part of the solution. All right, there's my thought to myself. All right, the last dot, -4, -1. Part of the solution? No, not in the shaded part. Cool beans, thanks.